Hello everyone. Today we are going to see the project name called Secure Face-Based Authentication and Message Transmission using AES Encryption and Image Steganography. So, in the current digital era, millions of messages and confidential data travel across networks every second. But these communications are continuously exposed to cyber attacks, identity theft, and unauthorized access. Traditional password based systems are no longer sufficient because passwords can be stolen, guessed, or shared. To address these challenges, this project introduces a multi-layered security model that brings together biometric authentication and image steganography into a single secure web application. The first layer is face-based authentication, which uses deep learning facial embeddings to verify user identity. This prevents impersonation and ensures that only legitimated users can access encryption or decryption features. After authentication, the message is encrypted using AES, one of the world's most trusted symmetric encryption algorithm. AES converts the text into unreadable using a strong key generated through SHA-256 hashing. Finally, the encrypted message is killed using LSB image steganography, which hides the ciphertext inside an image without alerting its visual appearance. This ensures not just security but invisibility of communication. All these components are combined into a Flash framework where users can register, authenticate, encrypt, hide, extract, and decrypt messages in a user friendly manner. This project ultimately provides a high secure, efficient, and practical communication framework for military, banking, government, and academic applications. So, this is our block diagram. The process begins with the input block, where the user provides three key elements: a facial image for authentication, a text message for encryption, and a secret key. This inputs acts as a starting point for both identity verification and message security. The next block is face authentication, where the system detects and encodes the user's facial features using a face recognition library. These encodings are matched with the trained dataset to verify identity. Only an authenticated user can continue further. Once authenticated, the system moves to the AES encryption block. Here, the user's secret key is transformed into a 256-bit key using SHA-256. The plain text message is then encrypted into cybertext using AES in ECP mode. This ensures the confidentiality of the message even if intercepted. This encrypted message is then passed to the cover image block, where a normal image is selected to hide the ciphertext. In the image technography block, the encrypted data is embedded into the latest significant bytes of the pixel values using the LSP technique. This creates a stegno image that visually appears unchanged but secretly contains the encrypted message. This stegno image is then transmitted to the receiver. On the receiver side, the process is reversed. The hidden ciphertext is extracted using the same steganography method and then decrypted using ACE with the correct key. Successfully decryption restores the original plain text message. Overall, this block diagram clearly shows a secure end-to-end pipeline where authentication ensures users legitimacy, encryption ensures the content, and steganography conceals the very existence of the message, forming a complete multi-layered security system. So this is our code. First, we are importing all the libraries, and then we are setting our configuration. Like we are configuring our training folder, labels, techno folder, Hardcashcare we are using here. This is the library for face recognition. Then these are all helper function. A is helper function and Stegno helper functions. Here that we are encrypting text, decrypting text, hide text, and extracting text. For those things we have defining helper functions here. So this is face recognition. Once face is captured, then it will be given into our training label. If the training label is identify the face, then it will allow us to encrypt or decrypt, or else it will throw error. So once if it is recognized means then it will tell the name along with the enrollment ID. So this is our index router. So this is the registration. For registration, we need to give enrollment ID, name, and then face we need to capture. If that face is captured, then that will be trained to our model. After training, it will be registered. This is our training phase. So in this phase, our images will be encoded and it will be training level. So this is authentication phase router. So in this phase is captured, then it will recognize the face. If that face is not recognized, means it won't allow us to encrypt. And if that face once the face is recognized, then it will tell the enrollment ID and the name. If we have any messages means, then it will tell that message like you got one message. So this is encrypt router. So in this encrypt router means once the registration we can encrypt a message with the image and the secret key and send. This is for decrypt. So in this decrypt section, here also first we need to recognize our face. Once it is recognized means only we can the image or else we can't able to do. So now we'll run and check once. So this is our web page. So here we have a register face, train model, encrypt message, and decrypt message. First we'll register our face. I'm giving the enrollment ID as 123. Name will register our face. Once registration successful, then we'll move on to our training model. So here we are trained our model. So training is in progress. Once after training, we'll encrypt our message. So first we'll authenticate our face. So once it is authenticated, it's telling the username along with the ID. So now we'll choose one image. I choose one image and I will tell secret key. So now secret key, before secret message, now we'll provide some secret key. 000 I'm giving as a secret key and I'm enrollment ID here. 456. Then we'll encrypt and hide our message. So once it encrypted, then it will give some messages like message hidden for 123 and our saved image also. So now we'll back to home. So now we'll decrypt message. For decrypt message also first we need face authentication. So once face authenticated means then it will tell the authenticated user jump and ID. So as of now I didn't get any decrypt messages. So if I choose the file, so I have choose the file which I have encrypted. So if I encrypt and I put the secret key, what the key I set for that image, then also it won't allow us to decrypt that message. If the user for whom I share, they only can access the decrypting the message. Or else they can't. We register with the another image along with the ID and name. So now we'll train that face also. Once training completed, so our that face will be stored. Once face authenticated, then that name and ID should be displayed. So now we'll do some encrypt secret key and the secret message and the receiver enrollment ID we are setting here. After setting, we got some messages like message hidden and that image will be stored. Now face authenticated means so it telling that username and the ID. So I do message alert. So if I do decrypt means it will allow before it doesn't allow me to do that decryption. So I need to provide the secret key. Once if you select this Stegno image and secret key, then it will display that message.